Jai Hind friends, myself Dr. Pankaj Goel, working as assistant professor in Akgec Engineering College. Now we will discuss about a very important topic of multiplexing, in which we will cover FDM and TDM, frequency division multiplexing and time division multiplexing. First of all, what is multiplexing? So, multiplexing is a technique which is used to combine and send the multiple data streams over a single medium. The process of combining the data streams is known as multiplexing, and hardware used for multiplexing is known as a multiplexer. Multiplexing is achieved by using a device called multiplexer that combines n input lines to generate a single output line, and multiplexing follows many to one, that is n input lines and one output line. Similarly, at the receiver we have to use a device known as demultiplexer, and demultiplexing is achieved by using demultiplexer available at the receiving end. Demux separate a signal into its component signals, that is one input and n outputs. Therefore, we can say that the demultiplexing follows the one to many approach. This is a block diagram of a multiplexing demultiplexing. Here we can see that there are, at the transmitter end we have n input lines, then the multiplexer combines these n input on a single channel, and at the receiver end, this is our transmitter end. This is our receiver end. At the receiver end, we have a demultiplexer in which the data values corresponding to different input lines are separated and transmit and sent to different output lines. So, the function of multiplexer is many to one, and the function of demultiplexer is one to many. Okay, many lines to one line, and here one line to many lines. Multiplexing may be time division multiplexing, frequency division multiplexing, or wavelength division multiplexing. Here in this session we will cover time division multiplexing and frequency division multiplexing techniques. First, let us discuss the FDM, the frequency division multiplexing technique. In frequency division multiplexing, multiple information signals can be transmitted over a single communication channel by occupying different frequency slots. This is very important to know. By occupying different frequency slots within the common channel bandwidth. And FDM technique is basically used for multiplexing of analog signals. This is the block diagram representation for a FDM transmitter. Here we can see that we at the input end, at the transmitter end, we have n signals. There are n different message signals which need to be transmitted over a single line. This is our single line. Now, how we can transmit n signals over a single line without any interference? In case of FDM, what we do? We use carrier signals of different frequencies, say FC1, FC2, FC3 and so on up to FCN. So if we have n input signals, then we have to use n different carrier signals, the carrier signals of different frequencies. Now, when these message signals are applied using a modulator to a modulator, then the modulated wave will have different frequency for each of these message signals. We can see here the modulated signals here. These modulated signals will have different frequencies. Now, all these modulated signals will have different frequencies, and therefore, when these modulated signals are transmitted over a single channel, they will not interfere, because all of them are modulated using different carrier frequencies. So, we know that if there are signals who are having different frequencies, they do not mix up, they do not interfere with each other. This is the block diagram for FDM receiver. Here we have to see that the different message signals are coming on a single line here. Now they need to be separated. So separated mechanism here is we have to use the band pass filter. Band pass filter, as we know, that filter which pass a signal of a particular frequency band and stop others. So this first band pass filter will pass a modulated signal of carrier frequency F1. Similarly, second band pass filter will pass a modulated signal of frequency FC2. This first one is FC1, then FC2 and up to FCN. So all these filters are tuned at different frequency values. First one is tuned at FC1, second one is tuned at FC2, then FC3 and FCN. Now by using these filters, we have separated different frequency signals, because different frequency signals are corresponding to different message signals. Now these, as we know, these are the high frequency signals. These need to be applied to the demodulators, and the demodulators will give us our message signals back. Message signal 1, message signal 2, message signal 3 and up to message signal N. So this is the block diagram for FDM receiver. Here again I want to reiterate that different information signals are transmitted over a single communication channel by occupying different frequency slots. Different frequency slots are given by modulating the message signals using different carrier frequency signals. And then at the receiver, using band pass filters of different frequencies, we can separate the different frequency signals from the combined channel. Now let us discuss the next multiplexing technique, that is time division multiplexing. This is one of the very important technique which is used in digital communication. FDM, as we discussed, is used in analog systems, TDM is used in digital systems and it is very important technique. In case of FDM, we discussed that all message signals are combined on a single channel and all these message signals occupy different frequency slots. But all these message signals exist at every instant of time. But in case of TDM, all these signals occupy different time slots. Instead of frequency slots, in case of FDM, all the signals occupy different time slots in TDM. So we can see here all signals operate at the same frequency with different time. Here in case of TDM, the total time available in the channel is distributed among different users. Therefore, each user is allocated with different time interval known as time slot, at which data is to be transmitted by the particular sender. Here we can say that one single user takes control of the channel for a fixed amount of time. After that, the control is given to the next user for a specified amount of time in which that user can transmit its data, and so on. Here again, note that in TDM technique, data by different users is not transmitted simultaneously. Data is transmitted simultaneously in case of FDM. In case of TDM, data is not transmitted simultaneously, rather one by one, by occupying different time slots. Now, this block diagram helps us understand further the concept of TDM. Here we can see we have n different senders who want to send the data. Now, we can see that we have divided our frame. We have divided our frame into n slots corresponding to n users, n senders. There are n senders, so we have taken n, we have divided our one frame into n slots, so that in every frame each sender can send its data. So here we can see this is the data from first sender up to the last sender, Sn. Then after frame 1 is transmitted, then second frame is formed, in which again first we will take the data from S1 sender up to Sn sender. This is our mux. Now, again see the TDM frames. Here we can see we have taken three sources A, B and C. Source A consists of data A1, A2, A3. Source B contain data B1, B2, B3, and source C contain data C1, C2, C3. Now, in the frame 1, we will have one data from each of the sender, each of the source A1, B1, C1. A1, B1, C1. Then in frame 2, we will have data from each of the source A2, B2, C2, and then in the last A3, B3, C3. And these frames are transmitted over a single line, single common channel. for this FDM and TDM technique, the book that I have referred is Simon Hakin, Top Schilling and George Kennedy. You may use these books for further study. Thank you.